In this video, we're going to introduce the concepts of probability. There are two approaches in solving for the probability. The first one is the classical approach. Classical approach assumes equal likelihood of occurrence. If an outcome can occur in n different ways, out of a total of n possible ways, all of which are equally likely, then the probability of that event is h over n. So, sorry, this is h. Example, suppose that we want to know the probability that a head will turn up in a single toss of coin. Since there are two equally likely outcomes, so that would be the two equally likely outcomes would be the head and the tail. So, assuming that it does not roll away on stand of its edge, so only two possible outcomes, head and tail. And of these two ways, a head can arise only one way. With that reason, the required probability is in arriving is 1/2. One of the two possible outcomes. In arriving at this, we assume that the coin is fair, not loaded in any way. So another example under the classical approach is throwing a die. So in throwing a die, the possible outcomes would be 1, 2, 3, 4, 5, and 6. So the probability that 1 would come out on a single roll of die is 1 out of the 6 possible outcomes. The next approach is the frequency approach. By the way, the classical approach is called the a priori approach, while the frequency approach is the a posteriori approach. Posterior, so after the experiment. So this is also known as the empirical approach. We base the probability from previous experiment. So if after n repetition of an experiment where n is very large, an event is observed to occur h of this, then the probability of the event is h over n. This is also called the empirical probability of an event. Example, if a coin is tossed 1,000 times and it comes up head 532 times, we estimate the probability to be 532. 532 over 1,000. In a random experiment, there is always uncertainty to whether a particular event will or will not occur. As a measure of the chance, the probability which we can expect the event to occur. It is convenient um, It is convenient to assign a number between 0 and 1. So the lowest probability should be 0 and the highest probability is up to 1 only. So for a sure event, the highest probability is 100% chance or 1. And for the impossible event, it has a probability of 0. So this is 1 for a sure event always happening and 0 for an impossibility. So impossible 0, sure 1. So we can say that the probability is a close interval from 0 to 1. If the probability is 1/4, we would say that there is a 25% chance that it will occur and 75% chance that it will not occur. And if we are going to have the odds ratio, equivalently, we can say that the odds against its occurrence are 75% to 25%. So 0.75 is to 0.25. We can multiply both by 4. So this would be upon multiplying 4. So this is 3 is to 1. P is are the designation that we will be using is P for the probability function. P of A is the probability of the event A. For equally likely outcomes, like on the case of the classical approach, we have the probability 1 over n. So for the discrete sample space, the probability of an event E is denoted by P of E, equals the sum of the probabilities of the outcomes in E. So we add the probabilities for certain events. The number of assignment to each member of a collection of events from the random experiment that satisfies the following properties. If S is a sample space and E is any event in the random experiment, the probability of the sample space should be 1. If you're going to consider all the events in the sample space, the total probability, the summation of the probability should be 1. And the probability of a certain event should range from 0 to 1. No negative probabilities and no probabilities greater than 1. For two events that are mutually exclusive, event 1 and event 2 would be an empty space. So such that P of probability of event 1 union with event 2 is the sum of their probabilities. Thus, if A and A prime are complementary events, so the probability of A plus the probability of A prime, since they are complementary, so it should add up to 1. So the probability for the complement of A is 1 minus P of A. So for example, the probability of raining is 0.4. The probability of not raining is 1 minus 0.4 or 0.6. Example. A box contains 500 envelopes. So we have n is equal to 500, of which 75 contains $100 in cash. So for the $100, we have 75. 150 contains $25. And 275 contains $10. So $10, 275. Let us verify if we are going to add that. It would be 75 plus 150 plus 275. So that is indeed 500. So an envelope may be purchased for $25. What is the sample space for the different amounts of money? So the different amounts of money are 100, 25, and 10. So these are the different amounts of money. This is the sample space. Assign the probabilities to the sample points. So if we're going to assign probabilities, the probability for 100, the probability for 25, and the probability for 10. Their corresponding probability would be the frequency over the space. So that would be 75 over so the probability for 100 is equal to 75 out of 500. The probability for 25 is 150 over 500, and the probability for 10 is 275 over 500. And then find the probability that the first envelope purchase contains less than 100. So the probability that X is less than 100 are the events that it would be 25 and 10. We can add these two probabilities such that we have 150 and 275 all over 500. So that would be 425 over 500. We can also compute this as not being 100. So not 100 is 1 minus the probability for 100. So that is 1 minus 75 over 500. So that is still 425 over 500. You may simplify your answers to check and check your works. Next, each coded item in a catalog begins with 3 distinct letters. So this would be letters. And then followed by 4 non-zero digits. So 1, 2, 3, 4. These would be non-zero digits. Find the probability of a find the probability of randomly selecting one of this coded item with the first a letter, a vowel, and then the last digit is even. So distinct, there would be 26 letters in the English alphabet, and then 25, and then 24 because of this being distinct. No repetition, so we are subtracting the number of possible options because we have selected one already. For the non-zero digits, so we have 9, and then since it is distinct, so you have 8, 7, and then 6. So for the probability that we are solving, it should be a vowel. So if it is a vowel, it can be A, E, I, O, U, so that's 5 options. For the second for the second letter, you have 25, so that's 26 minus the first character. And for the last, it would be 24. And then 1, 2, 3, 4. It must be even. So how many even non-zero digits do we have? So we have 4. 2, 4, 6, and 8. And then from the 9 options, we have now 8 because we have chosen one already, 7, and then 6. We are going to divide this by 26 times 25 times 24, 9, 8, 7, 6. Observe that I haven't simplified this because I would be canceling out 25, 24, 8, 7, 6. So 8, 7, and 6. So what's left would be 5 times 4 over 26 times 9. So we can simplify this. You can use your calculator. 5 times 4 over 26 times 9. So that is 10 over 117. If if a letter is chosen at random from the English alphabet, so N is 26. There are 26 letters. Find the probability that the letter is a vowel. So there are 5 vowels, so that is 5 over 26. It is listed somewhere ahead of the letter J. So that's A, B, C, D, E, F, G, H, I. So that's 9 letters. So 9 out of 26. Listed somewhere after G. So instead, since letter G is on the first few letters, let's get the complement. 1 minus. After G, so let's count the letters from A to G, and then we have the complement of that is H onward. So A, B, C, D, E, F, G. So that's 7. So 1 minus 7 over 26. So that would be 19 over 26. Consider tossing a die or a pair of die twice. Or sorry, tossing a pair of die. So that would be 6 on the first toss and 6 on the second toss. So that would be a total of 36. What's the probability of getting a total of 8? What are the possible totals? What are the possible combinations that would give us a total of 8? We can have a 4-4, correct? We can have a 5-3 and a 3-5. So that's a total of 8. We can also have 2-6 and 6-2. Can we have 7-1 and 1-7? Definitely no, because our die is 1, 2, 3, 4, 5, 6. So we can't have a 7. So all in all, how many? 1, 2, 3, 4, 5. So that would be 5 over 36. At most, a total of 5. So a total of 5 means we can have a total of 5, a total of 4, a total of 3, and a total of 2. A total of 5 means we can have 3, 2, 2, 3, 1, 4, and 4, 1. A total of 4 means we have 2, 2, 1, 3, 3, 1. A total of 3 means we have 1, 2, 2, 1, and the total of 2 is 1, 1. We can't have a total of 1. So all in all, we have 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So that is 10 over 36 equal to 5 over 18. A poker hand consists of 5 cards. Find the probability of holding. So a poker hand has 5 cards. There are 52 cards in a deck, and you're going to select 5. So that's 52 combination 5. What's the probability of holding 3 aces? So we have 4 aces and we're going to select 3. And then after that, since we need 5 cards, we're going to get the rest. So all in all, we have 52 cards, but we already have selected or identified that we will be only taking 3 aces. So for the non-aces, we have 48. And then we're going to select, since we need 5, we already have 3. So we take 2 more divided by 52 combination 5. So that would be 4 combination 3 times 48 combination 2 divided by 52 combination 5. So this is 94 over 54, 145. How about 4 hearts and 1 club? How many hearts does a standard deck have? 13. So from 13, we choose 1. We choose 4 rather. And then from 13 clubs, we choose 1. Divided by 52 combination 5. So this would now be 13 combination 4 times 13 combination 1 divided by 52 combination 5. And that would be 143 over 39984. You have 3 books to be picked at random from a shelf containing 5 novels, 3 poems, and 1 dictionary. So all in all, how many books do we have? 5 plus 3 is 8 plus 1 is 9. What is the probability that the dictionary would be selected? So we are going to take 3. The sample space is from the 9 books, you're going to select 3. So what is 9 combination 3? 84. So this is 84. So if we are going to select the dictionary, out of the 1 dictionary present, we're going to choose the dictionary. And from the 8 other books, 5 and 3, from the 8 other books, we need to select additional 2 books. This is to be divided by 84. So this is now 1 combination 1 times 8 combination 2 divided by 84. So this is 1/3. 2 novels. So from the 5 novels, we're going to choose 2. And from the 3 points, we're going to choose 1. This is again to be divided by 84. So that's 5 combination 2 times 3 combination 1. So that's 30 over 84. You can simplify that if you want. Next, a fleet of 8 taxis is to be randomly assigned to 3 airports. So you have 8 and you're going to assign them into 3 airports, A, B, and C. So A, B, C. 2 going to A, 5 going to B, and 1 going to C. How many ways can this be done? So that's 1 out of 8 factorial over 2 factorial, 5 factorial, 1 factorial. So that's 8 factorial divided by 2 factorial times 5 factorial times 1 factorial. So this is 1 out of 168. What is the probability that the specific cab driven by Jones is assigned to airport C? So since there's only 1, so that means we're just going to have the remaining 7. We fix Jones here. So from the 7, we're going to have 2 and 5. So that's 1 out of 7 factorial over 2 factorial, 5 factorial. So this is 1 over 21 if Jones would be on a specific airport. Let's leave this as your exercise. Try to work on this and discuss this on the online discussion, on the online meeting that we will be having. So that's all for this lesson. So continue on the next video presentation.